Welcome back to the third episode of How to Make Banana Prints. So in the last episode, we started implementing the player movement, and our player could move and flip directions. Now the only thing left is switching to the run animation when moving. So to do that, let's bring out the Animator window from Window, Animation, Animator. And this will put the Animator in the top bar here. If you don't like this layout, you can drag it and place it wherever you feel more comfortable. So now let's click on the player renderer. And if you look now in the Animator window, we can see the two animations we created earlier. So let's organize the animations a bit, so we can drag it like this. Alright, that looks much better. Now in Unity, each animation inside the animator is represented by a rectangle and is called a state. If you notice, you can see that the idle animation or state is orange, while the run state is gray. That's because the idle animation is set to be the default animation, which means that each time we start the game, our player will be in the idle animation because it's the default state. To change the default animation, you can right click and choose Set as Layer Default State. But we don't need to do that in our case. So now in order for our player to be able to switch between animations, we need to create transitions between the animation states. So to make a transition from the idle to the run state, we can right click on our idle state and then select Make Transition and then click on the run animation. Now we should see an arrow drawn from the idle to the run state. And if you click on this arrow, we can see the transition properties on the right side here inside the inspector. So we will come back and configure them in a second. But first, let's create another transition from run to idle by repeating the same process. So now to determine when to change from the idle state to the run and when to go back to the idle state, we need to use transition parameters, which can be set through our code to tell the animator to go from one state to another. So to create new parameters, we need to go to the Parameters tab and then press the plus sign. And here we can choose the type of our parameter. So I'll go ahead and select bool for this one. And I'll rename it run. Now let's click on the transition from the idle to the run animation. And here inside the transition properties, under the conditions section, we press the plus sign to add a new condition. Now you can see that run was added automatically. And that's because it's the only parameter we have so far. So here we can choose the value for the condition. So if it's true, our animator will transition from idle to run when the run parameter is equal to true. And if it's false, it will transition when the run parameter is equal to false. So now to go from idle to run, the value is going to be true. And let's go to the other transition. And here the value is going to be false. Now one more thing we have to do is unchecking the hasExitTime property for both transitions. And one final thing we have to do is from the settings here, we need to set the transition duration to 0. Because we want our transition to be snappy. Alright, so now let's go back to our player controller. And under the components header, we can add a public animator. Let's call it anim. And in the awake function, let's get a reference to it. So anim is equal to. So if you remember, our animator component is attached to the player renderer and not to the player game object. That's why to get it, we need to use the getComponent in children method. And let's pass the animator. Great, so let's save. And now back in our ground movement script. So after we flip our player, let's set the RAM parameter. So we type playerController.anim.setBool because we have a boolean parameter. And we want to set the RAM parameter. And the value is going to be that the horizontal movement is not equal to 0. So that means that if the player is moving, the horizontal movement is not going to be 0, and the condition will be true, so the run parameter will be set to true, and otherwise it's going to be set to false. So now let's save and check if everything is working. So back in Unity. So now let's go to the game view and hit play. So we can see that our player can move now and flip, and the animation is running as well. Oops. Alright, that's a problem. So we need to go to the RigidBody settings, and from the constraints, let's make sure we freeze rotation. So if we try now, yeah, it's working, but we can see that the player is getting stuck. And to solve this issue, we need to add a composite collider to our tilemap. So let's go to the ground collider tilemap. Let's add a composite collider 2D. And here in the tilemap collider 2D, let's check used by composite. And for the RigidBody, let's change the type to static. So this issue is caused because each tile has its own collider, And since our player has a box collider, it gets stuck sometimes. But when using Composite Collider, it merges all these small colliders into one big collider. So now if you play again, we should not see this issue again. So yeah, awesome. Now the last thing we need to do is making the camera follow the player when he's moving. So let's go to the scripts folder. Let's create a new folder. Let's call it camera. And inside it, we create a new script. Let's call it camera controller. And let's open it. So we remove the default functions. And at the top here, we will need a reference to our player. So let's make serialized field, private transform. Let's call it player. So now let's analyze the behavior of the camera from the original game. So we can see that the camera has 3 requirements. First, the camera follows the player when he moves to the right only. And second, the camera bounce has like an invisible wall, so the player cannot pass through it. And finally, when reaching the end of the level, the camera stops moving. So for the first requirement, to make the camera follow the player when going to the right only, inside our update function, we can check if the player position on the x-axis is greater than the camera's. So in that case only, the camera will follow the player. So let's create a vector 3. Let's name it desired position. Let's set it to a new vector 3. So for the x value, we will have the player.position.x. And for the y value, it's going to be the same. And also for the z value, we will not change anything. After that, we can set the transform.position is equal to the desired position. So if you save and go to test it. So let's go to the main camera. Let's add a component, camera controller. And let's drag our player to the player. And let's play. And now if we move our player, we can see that the camera follows him, but when he goes to the right only. Now for the second requirement, the player should not be able to pass the camera bounce like this. So let's go back to our camera controller and let's create 2 floats for the right and left bounce. So public float, left bound, and public float, right bound. Now we will need a reference to our camera as well. So let's make a private camera. Let's call it cam. And let's get it in the awake function. Cam is equal to get component, camera. So now let's make a function to get the camera bounce. So after the update function, we will have public void get camera bounce. So now to get the camera bounce, we will use the camera orthographic size, also known as the half height, which is the visible area from the center of the screen to the top in Unity units. So to get the horizontal distance from the center of the screen to the right or left bound, we need to multiply the half height by the device resolution or the aspect ratio, which is basically the screen width by the screen height. So in that case, our right boundary is going to be the camera position plus the horizontal width from the center, and the left boundary is going to be the camera position minus the horizontal width from the center. So let's now assign these values to our variables inside the function. So our right bound is going to be transform.position.x plus, so we have the camera orthographic size first, times the screen width by the screen height. That's it. And for the left bound, we can just copy the same line and just change the plus to minus. And now we need to call this function each time after the camera moves. So let's call it here, get camera bounce. And also let's call it inside the start method. So let's call the start method. And here we can get the boundaries as well. So let's save. Now we can go to the ground movement script. And down here we can create a new function. So public void, let's name it restrict player movement. And here we need to clamp the x value of the player position. So let's create a new vector 3. Let's name it current position. And it's equal to transform.position. Then let's clamp the x value of this vector 3 So we can write current position.x is equal to mathf.clamp, and we want to clamp the current position.x, and the minimum value is going to be the left bound of the camera. So let's get our camera by writing camera.main.getComponent camera controller dot left bound, and for the maximum value it's going to be the right bound. So camera.main.getComponent camera controller dot right bound. That's it. But these values will make half of the player only in the screen. So to fix that, we can add an offset. So for the minimum value, we can add plus 0.5. And for the maximum value, we can subtract 0.5. So after that, we can set the player position equal to the modified position. Now let's call this function after our player moves. So let's call it here. So now let's save everything and go back to Unity to test it. So if we hit play now, we can try to move and then try to pass the bounds. And as you can see, our player cannot pass the bounds. And now for the last requirement, our camera should stop when reaching the end of the level. So let's go back to the camera controller and let's go to the top and create two floats. So we will have a public float, level left bound, and another one for the right bound. Now let's go back inside the update function. When we get the desired position, so here after we get the desired position, we can clamp the x value of this vector. So desired position.x is equal to mathf.clamp. So the value is going to be desired position.x. The minimum value is going to be the level left bound, and the maximum value is the level right bound. So that's all we have to do. So now let's save and go back to Unity. So let's go to our main camera and let's set the values. So the left bound is going to be 0 and the right bound may be 12. So let's see. So let's move. Nah, that's too much. Maybe 5. Let's move. And yeah, you can see the camera stops moving. And with that, we're done for this episode. And next time we'll be making the player jump, so stay tuned. If you enjoyed or learned new things in this one, please like and subscribe. And if you want to get notified when the next episode is out, don't forget to push the notification bell. And as always, never forget to save your projects, and I'll see you next time.